All right, so I'm going to go over the key things you need to be able to do to be successful on the test. One of the things it asks is, what is true of a solution that's basic? Well, here's the way it works. If we say something is neutral, it means the H3O plus and the OH minus are basically equal. That's what water is when it's a pH of 7. If the H3O plus is greater than OH minus, that's when something becomes an acid. If something is a base, that means you have greater amounts of OH minus than H3O plus. So if we say something's basic, that means we have to have a greater amount of OH, so C is the correct answer. Next one, it asks which one of the acids is the weakest. We tell Ka tells us the strength of the acid. Notice they're all negative exponents, so we're looking for the smallest value for Ka. The smallest Ka value is going to be equal to the weakest acid. So if you notice, look at the exponents. That's -5, -4, -3, -2. A is the correct answer because the smallest Ka, largest negative exponent means smallest, which is the weakest acid. If you look at number 3, 3 is asking about neutralizing. Remember the formula MaVa is equal to MbVb. And then you pay attention to the number of the OHs in the formula and the number of H3O pluses. That's how we calculate this. So when we go to calculate it, if you notice, first thing I zoom in on is there's 2 H's in the formula, so there's 2 H3O pluses. The molarity is 0.100. The volume is 40 milliliters, so I'll put 40 milliliters right there, equals the molarity of the base is 0.200 m. The volume of the base is going to be VB. I just add that in, and notice there's only one OH there, so I just add a 1 there, and then I solve it. Do the math, you're going to end up with C would be your correct answer after you do the math for that one. When we talk about an acid-base titration, this is just memorization. You have to know it's a neutralization reaction, because if you think about it like this, NaOH plus HCl, for example, right? You have it, the OH provides the base, the H is the acid. When you combine the two together, the first thing you're going to get is you're going to get water, and then, like in this case, NaCl, you get what we call a salt. But that's what a neutralization reaction is. Look right here, number 5, which represents a neutralization reaction. So look for the OH. No OH in that one. B goes, no OH, no OH. If you notice right here, I see OH there, and I see a little H there, which represents an acid. That's why 5A is correct. If OH is this, what would the H plus be equal to? Well, remember, on the top of pH land, H3O plus times OH minus is going to be equal to 1.0 times 10 to the negative 14th. So all I'm going to do is I'm going to take my OH, which is 1. This in this case 1 times 10 to the negative 14th. 1.1 times 10 to the negative 4th. All I have to do is put that downstairs and divide the two, and I will always get the other one. So in that case, 6, the correct answer is going to be 1 times 10 to the negative 10th. Which of the following are the conjugate acid-base pairs? Remember the difference in a conjugate acid-base pair. So when we talk about Bronsted-Lowry, like I have HBr here and then I have Br there. So that would represent a conjugate acid-base pair of H2O and H3O plus. Those are pairs because the difference between them is one side has an H, either an extra H and loses it, or one gains an H. So that's basically what we're looking at. So for number 7, HBr and Br minus represents an acid, because it has one H here and it has 0 H's there. That makes that a conjugate base. Next one, 2 Bronsted-Lowry bases. The definition of a base is that it gains an H. So if you think about it like this, NH2 minus plus H2O, arrow, NH3, and then I'm going to get plus Br minus. If I look right here, did I copy that right? No, I copied the wrong one. Hold on a second. It's going to be OH minus. So it's OH minus. Look, this is 2 H's. That has 2 H's in it. That has 3. That has 1. So going from here to here, because the NH is there, it gains an H. It goes from 2 H's to 3. That makes that a base, right? Going this way, this has 1 H, and it ends up with 2 going the other way. So the two bases are going to be NH2 minus and OH minus. A would be the correct answer for that one. 9. Which statement, if a solution has a pH of 3, what does that mean? Well, an easy thing to remember it is when anything has a pH like of 3, it just means the 1.0 times 10 to the negative third would be the concentration of the H3O plus, because when we basically go 10 to the negative, that's what you end up getting anyway. And we already know a pH of 3 is acidic, so we would eliminate C and D, and then we don't have positive exponents really for any of these values that we have. See how that's a positive exponent? You could eliminate that as an answer choice. Which formula represents a salt? Well, the OH right there is a giveaway. That is a base, so we cancel that. The H on the front of that makes that an acid, and the OH there makes that a base. So a salt is an ionic compound, so it doesn't have H or OH. That's why B is the correct answer. According to Bronsted-Lowry, an acid is any species that can, we don't care about electrons in this chapter, so we're going to, well, Bronsted-Lowry wise, we don't care. Lewis, we do. It has to do with an acid donates a proton, so A would be the correct answer. Conjugate base. If they're asking you what a conjugate base is, all you do, when it says a conjugate base, it means rip an H off. Wants a conjugate acid, you add an H. So if I have H2PO4 minus, just take an H off. So instead of 2, there's going to be 1, and it's going to make the charge become 1 more negative. So that's what I end up getting is C for 12. Next one. What unknown quality can be found during a titration? Remember, this is the titration equation. MAVA equals MBVB. So they're either going to ask you the molarity of the acid or the base, or they could ask you the volume that you used. So what unknown quantity? Well, you'd actually measure the volume though. So when it says unknown quantity, it's basically going to be the concentration. That's why we titrate, to find the concentration of an acid or a base. 14 says triprotic. Triprotic means 3 H's. So like this, H3PO4 means in the formula there's 3 H's. That would be triprotic. If she asks you diprotic, notice here, H2SO4, see the 2 right there? That's diprotic, and monoprotic just means 1 H. Next one, 15. She's giving you H3O plus. What is the pH of the solution? Well, remember pH land. If you have H3O plus, anytime you just take the negative log of it, you get pH. So all I have to do in my calculator is take 8.26 times 10 to the negative fifth, take the negative log of it, and you should get C. Now, remember when it starts, that has 3 sig figs on top. That will become decimal places on the bottom. So that's why you have 3 decimal places in your answer there. 16, OH, and they're giving me in HNO3, another pH land problem. H3O plus times OH minus is equal to 1.0 times 10 to the negative 14th. They're giving me HNO3 is 0.250. So all I have to do is take that 0.250. Well, let me grab that like that. All I have to do is take that 0.250. Ay caramba. 0.2. Let's try it again. All I have to do is take that 0.250 and put it downstairs, and you're good to go. And you would find the OH minus concentration. Comparison, strong acid, strong base titration. Strong acid, strong base titration. So it says a weak base titration. Remember, a weak base, when it gets titrated, think weak base is going to be below 7. So a strong and a strong is always going to be at 7. So if this is below 7, that means a strong would occur at a higher pH. Next one. It says, which of the following occurs titration of sodium hydroxide with hydrochloric acid? So you're titrating sodium hydroxide, which is a base. So that means it's a strong base, so it's got to start over 12. We'll see how that starts, because think of 7 here. That can't be it. That can't be it. And it says with hydrochloric acid. So hydrochloric acid, we're going to finish. If it's a strong base, it's going to start above 12. That's why A is the correct answer. It's going to start way up here, and it's a strong acid. It's going to finish way low. Next one. 3 properties of acids and bases. You can just look those up in your notes. pH range for an acid is going to be 1 to like 6.9999. pH range for a base is going to be like 7.0001 to like a little bit past 14. Same thing here. She's giving you hydrogen ion concentration, which is the same thing as H3O plus. She wants to know hydroxide concentration. So it's the same thing we've been doing. You're going to just take 1.0 times 10 to the negative 14th. You're going to divide by 2.34 times 10 to the negative 5th, and you get your answer. Next one, pH of the solution. Hydrogen ion concentration, H3O plus. Remember pH line, you want to write it right before you get started. All you have to do is take the negative log and you get your answer for that one. Let's see here. 24. If the hydroxide ion, same thing. We did that over. Okay, this is basically all pH line. You guys are good with that. What are the products of a neutralization reaction? A neutralization reaction is always going to produce water plus what we call a salt or an ionic compound. What is the point in the titration where moles of OH actually equals? That's what we call equivalence. Equivalence is when moles of the acid are equal to moles of the base. Boom. Next. What is the point in titration where OH exactly equals? It's like the same thing. Okay. What is the concentration? Look at this. Neutralizes. So I'm going to just bust out MAVA equals MBVB. So what I do is I'm going to take my 0.25 of my base. 25 milliliters is what neutralizes it, is my volume. I see 1 OH, I lied, 1 OH in the formula. I come over here, HCl, I see 1 H. I see the volume is 100 milliliters, 100.0 milliliters, and then X is I'm solving for the molarity. That's all I do. I use MAVA equals MBVB. Just remember I have H3O plus on one side, and I have the number of OH minus on the other. Same thing here with 30. When you go to do 30, just be careful with the parentheses. There's double OHs. So I take my molarity of my base is going to be 0.25. 25 milliliters of the base, it says. And I have 2 OHs equals 100 milliliters of my acid. And the number of H's I have is 1. And I'm going to pop in my X there. Same thing we did before. This is my MA is going to be my X. My volume of the acid I got from right there. The number of H's I got from it's always the formula. And the number of OHs I got from the formula as well. Difference between a strong acid and a weak acid. A strong acid ionizes or breaks apart completely. So 100% breakup for a strong acid. Whereas a weak acid breaks up like about 5%. So one thing we say is completely disassociate. I think that's a language she likes to use. So it's like when you disassociate with someone, you break up with them, you're completely disassociating if you're a strong acid. Conjugate acid is a base that has an accepted in H+. So whenever you have a conjugate acid, you have a base. So like example would be if I took NH3 and I have it with, if I did this, NH3 plus water, for example, I'm going to get OH minus plus NH4 plus. This side has 3 H's, now it has 4. So conjugate acid is the base that is accepted in H+. Following reactions identify acid-base conjugate acid. So if we look here, this says 1 H, 2 H's, 3 H's, and 0. I have the NO2 there and there. It goes from 1 to 0. That means that's going to be my acid. Automatically makes that my conjugate base. This has 2. It goes to 3. It goes up. So that means this is a base. Conjugate acid. If you look here, 0 H's, 2 H's, 1 H, 1 H. CN is here and here. It goes from 0 to 1. That makes that a base. That's a conjugate acid. This has 2 to 1. That makes that an acid and a conjugate base. Notice it says Ka. So as soon as it says Ka, I know X squared over molarity is equal to Ka. Well, what is she giving me? She's giving me the molarity and she's giving me H+. Don't forget to square it. That's the most common mistake. So I'm going to go 0.300 on the bottom. I'm going to take the 3.5 times 10 to the negative third on the top. There's your setup. Square it. Bam. Check the answer. You're good to go. Find the pH. Notice it says Kb. When I go to do that, remember it means Kb means base. So it's X squared over molarity is equal to Kb. When I find X, I'm getting OH minus. So watch what I do. I got my molarity I put on the bottom, 0.0750. X squared on the top equals 4.92 times 10 to the negative 7th. So the first thing I'm going to do is multiply that times that. Then to get x by itself, when I get that answer, I'm going to square root it. When I get that answer, it's OH. If I just take the negative log of it, I'm going to get POH. The last thing I have to make sure I do when it's KB is I have to remember to subtract from 14. So take whatever you get. So multiply 0.0750 times 4.9 times 10 to the negative 7th. That's going to be equal, x squared is going to be equal to that answer, whatever you just got. Then you take the square root of that answer, you get x. Then that x is the same thing as OH minus. You take the negative log of it, and then you go from here. Look how tricky this is. See the OH in parentheses? Before you even start, you just take 0.00675, multiply by 2. Then you go into pH land and find pH. So I'd have OH concentration, negative log, subtracted from 14. All right? Hope this helps.